All right, guys, here we go with Mega CBA Review Day 3. Hopefully all the sound and everything is fixed this time so you can actually hear me. Let's go ahead and start off here with number 1. What is the precipitate when you mix barium chloride and sodium sulfate? So we're going to do a regular double displacement reaction here. So barium chloride, we need to know that that is BaCl2 because barium has a charge of positive 2 and chlorine has a charge of negative 1. Make sure you pop, drop, and swap there. Chlorine, because it's chloride there, not chlorate. And sodium sulfate. We've got Na and SO4. Na has a charge of positive 1. Sulfate has a charge of negative 2. Pop, drop, and swap. We get Na2, SO4. So we're going to make that into a equation here. So barium chloride, BaCl2 plus sodium sulfate yields. So we're going to have to trade partners here. Positive goes with negative and negative goes with positive. So barium is going to come into contact with sulfate. Which BaSO4. Barium is still positive 2. Sulfate is negative 2. So we don't have to do anything else to that. Sodium chloride. NaCl, salt. That should be fine as well because we have a positive 1 and a negative 1. So typically what we do here next is balance, so we'll put a 2 here. And now we want to know which of these new products is they precipitate. So that is when we're going to flip onto the back of our periodic table. We should look at the list of solubility rules. And we'll see that sulfate is usually on the list of soluble compounds, but when connected to barium, that is an exception. So this is no longer aqueous, this is solid. That is our precipitate. NaCl will definitely dissolve in water. Number 2, this is just straight up vocabulary. Oil and water, when you put them together, they don't mix. So the word for that is they are said to be immiscible. Easy peasy. Next one. What are the products and states of matter obtained when mixing two aqueous solutions of nickel 2 nitrate and ammonium sulfide? So just like we did here on number 1, except they're actually giving us the formulas. So we have NiNO3 plus NH4 2S. Again, we're going to combine the positives with the negatives, trading partners. So nickel, the only thing that it's going to attach to is sulfur. Now, we have to keep in mind that we always have to look at charges here. So we have nickel and sulfur together. But nickel is a transition metal, so we don't really know just by looking at the periodic table what its charge is. So we have to go look at it from the front. So nickel, and then we have 2 nitrates. Well, nitrate has a negative 1 charge. And since there's 2 of them, that means nickel has to have a positive 2 charge. That's not going to change from the left side to the right side. So nickel is positive 2, and sulfur is negative 2. So that's fine. We're going to keep it like that. And ammonium is going to attach to nitrate. So we have NH4, NO3. Now, I've seen a lot of confusion with people actually bringing this 2 over to this side, but that's something that you can't do. The subscripts that come with it only have to do with what the charges are. So this is fine, and then we would put a 2 here. Now it says they also want the state of matter, so you need to go through and check your solubility rules. Let's go ahead and do it for everything. So nitrate always dissolves, aqueous. Ammonium always dissolves, no exceptions, aqueous. NiS. Sulfur is on our list of insoluble ions. So when it's connected to nickel, nickel's not an exception, so that's solid. That's our precipitate. This is also aqueous. All right, number 4. Write an equation that shows the following. Aqueous silver nitrate and sodium chloride react. Just writing a full equation here. Silver nitrate, AgNO3, and they told us it's aqueous, so let's go ahead and roll that. Sodium chloride, NaCl. Sorry about the barking, guys. Stop. So we've got silver and chlorine together, AgCl plus NaNO3. And this just comes from trading partners again. Again, nitrate is always dissolvable, so that is aqueous. Silver chloride. Chloride is on the list of ions that are usually soluble, but one of its exceptions is silver. So that is solid. We have a precipitation reaction. Write the equation. Calcium chlorate mixes with ammonium phosphate. So this is still just what we've been doing on the last few. Calcium chlorate. Remember, that's chlorate with ATE. So this first one is CaClO3, but we have 2 of them because calcium has a positive 2 charge, chlorate has a negative 1 charge. Ammonium is positive 1, and phosphate is negative 3. So we have NH4, but there's 3 of them, and PO4. Calcium is going to combine with phosphate, so we have Ca3PO4 2 after we pop, drop, and swap, and ammonium chlorate. Yeah, we got a lot of balancing to do here. So calcium, we see we have 3 of them over here, so let's pop a 3 right here. That gives us 6 chlorate. So let's take the 6 right here. That also gives us 6 ammonium. So we'll put a 2 right here, and we should be balanced. All right, guys, that's it for the first page.